I want you to graph 1 over x minus 4. So you have to make sure you know the basic shape, and we're going to take that and we're going to graph it here. So if you had to sketch out the basic shape here, what do you know? Who's the basic shape? Come on. Isn't it that reciprocal function looks like this? Okay. And what am I doing with this guy? Are you asking or are you saying? You are going down 4. Because notice that this minus 4 is outside the function. This is your function, 1 over x. Is the minus 4 being done in the denominator with the x or outside of the fraction? Outside of the fraction. That's why he's being moved down 4.
So the 1 x has to be in parentheses and not just the 4.
Say again?
I'm trying to figure out how to enter it.
If you, well, you can do, you have to understand how the calculator reads the order of operations. You can type in 1/x minus 4. Because as soon as you step out here and you do minus, the calculator knows that it's not connected to this division. Division is a form of multiplication. It's got to stick those guys together. The minus 4 is disconnected. If you put parentheses around that, it's still going to be the same thing.
I did around the 4.
If you include the 4, that means the 4 is included in the denominator.
Just the 4.
Like 1 over x and then parentheses minus 4?
No, minus parentheses 4.
Well, that's kind of superfluous. You don't really need that. Now, I'm shifted down 4, so let's put my horizontal asymptote, right? It was right here at 0, so where is it now?
Negative 4. It cannot equal negative 4.
Well, on the edges it approaches negative 4. I could cross it. This guy doesn't, but I could.
Yeah.
What is your vertical asymptote? What makes that denominator equal 0? 0. Did I shift him left or right? No. So if this was your vertical asymptote right here, and you just shift this up or down, it's still going to be right here on the y-axis, right? But notice, you start off right here. And what did you do with this guy? You shifted it down 4 units, so that's why it's right here. You didn't shift left or right. Now you've got to know your key points. This is regular 1. So if you treat this as your new origin, do not color in this point, maybe make an open circle. I know that's my origin. My key points will be based off of that. 1 reciprocal is 1. The reciprocal of 2 is 1/2, and so on. The reciprocal of the reciprocal of 1/2 is 2. All these points that I find here, I can rotate them about this point. So I'll have my other key points just like I described before. The reciprocal of -1 is -1. The reciprocal of -2 is what? -1/2 from that asymptote. Remember how we're measuring from the new set of axes that we have? And now you've got to get your shape here. Make sure you do draw this accurately. Now again, it may look like I'm crossing those asymptotes, but the graph really doesn't do that. Isn't that just like my regular reciprocal function shape? And here we go. Now you see the limitations here with one ply. It's not going to graph all the way up here, but we know that it is going all the way up there. You've got your horizontal asymptote running right along here. You get your vertical asymptote right here. Questions about that? And let me talk to you about something about how you graph things correctly. When you graph, you will not do this. I'm just gonna, there we go, I'm gonna do that, I'm gonna do this. Is that right or wrong? Wrong? Are you sure it's wrong? Look what happens if I do this. What if I just failed? This class. No, I failed the vertical line test. You don't see me doing that, right? If this is supposed to be an asymptote, I'm going to get close to you. I'm getting close. Now I'm going away. Sorry. It's not you, it's me. Yeah. Definitely not easy, right?
You're an asymptote tease.
Asymptotic. You're using that as an adjective, so you would use. This is also something else you don't. You don't do this, but a graph in a different color so you can see how ridiculous this is.
That's awesome.
Is there a graph that looks like that?
Is there a graph that goes like
Is
that?
there a function? Kind of, no? It would be-
If you were to increase the power of the x as an odd power, as that goes to a larger odd power, it starts to look closer and closer to this.
Or zoom way out on your calculator.
Yes. Remember the power functions that we did yesterday when we talked about x squared, x to the fourth, x to the sixth? It was like it was a parabola. But then as you increase the powers, it started to get steeper on the ends and flatter in the middle, right? So it looked kind of like a box. Same thing would happen here if you increase this. It will never ever come to a sharp corner like that, but you could approach that.